Okay, I'm back for more multiplication rule. So what we're going to do is use the multiplication rule part number 1, and we're going to discuss why these events would be considered independent events. So let's take a look at the example we're being given here. Remember, I am still on page 4 of our Unit 2 packet, okay? So I just want to make sure we're all looking at the same thing. All right, let's go ahead and read together. It says, a box contains 30 different spools of ribbon. Okay, so this is our total in S, okay? This is our entire sample space. Now let's keep reading. We know that 12 spools are pink, 7 are green, 6 are white, and 5 are gold. So I'm actually going to make a little running list on the side here of the information we were just given. All right, let's do it at the top. We know that 12 of these are pink. I'm going to use the letter P. 7 are green. I'm going to use GR for that. 6 are white. And 5 are gold. I'm going to use GO for that. So now we know that this is going to sum to 30 total. All right. And we'll just make sure that we box up the page 4. So that's also clearly not part of this piece. Okay. So let's talk about the first part of the question. Let's finish reading the question. Oh my goodness. It says, I reach into the box, select one spool of ribbon, record its color, put it back, and select a second spool. This is called with replacement. Okay, so let's just be clear. We reach into the box, we take a spool of ribbon, we look at it, we write the color down, and we put it right back in the box. We do not alter the sample space. I just want to be clear here. Because we are replacing the ribbon, the sample space stays the same every time we reach our hand into the box. So let's answer our first question. Are these events independent or dependent? Well, if we do not alter the sample space because we keep replacing the ribbon, then that means these events are independent. I'm going to write that the sample space is always the same. Okay, so if these events are independent, I'm going to grab a different color to write the rule for multiplication for independent events. I'm going to write it in the bottom left-hand corner. So remember that because the events are independent, then the probability of A and B is going to equal the probability of A times the probability of B. And this is for independent events only. Okay? So let's backtrack and see what our first question is for letter B. First, we're asked, find the probability of selecting one pink spool and one green spool. So we want one pink and then one green. So I'm going to use the notation I did above. That would be pink, and then the word in between is and green. And based on what we wrote for our formula, that would actually look like the probability that the spool was pink times the probability that the spool was green. Now, when I'm in a with replacement problem, I actually always start with the denominators first. So I'm going to go ahead right away and set up two fractions. I am going to reach in this box twice. And every time I do that, there are 30 spools of ribbon. The first time I reach in, I'm hoping for pink. So there are 12 pinks out of 30 total. The second time I reach in, I'm hoping for green. There are 7 green ribbons out of 30 total. Remember, every time I reach in the first time, I'm just going to look at the ribbon and put it right back. So nothing is changing. If I multiply these fractions, I get, I'm going to write actually the fraction answer, which I got was like 84 over 900. But what you're really interested in is the decimal. So if you put this in your calculator, this becomes 0.0933, right? When I round to 4 decimal places. If you've started your ALEKS homework, you'll already notice we are rounding to 4 decimal places. All right, let's keep going. Now it says find the probability I select 1 white spool and then 1 gold. So this is very similar to part B. 2 different colors. It says white and then gold. So this would be the probability it is white times the probability it is gold. So for us, that would look like 2 fractions with 30 as the denominator. And remember, we need to know how many spools were white. That's my first numerator. So I look up at the top and there were 6. And then I look at how many spools were gold. And that there were 5. So together, if I find the final answer as a fraction, it's 30 over 900. Or if I put that in my calculator for the decimal version for ALEKS, that would be 0.0333. Okay, so let's take a look at the next one. The wording has changed. It says find the probability of, that part's the same, selecting 2 green spools back to back. Okay, so this one is green, GR for green, and green again. So still based on our rule for independent events, that means we're going to take the probability it's green and multiply by the same exact number, the probability it's green, a second time. So if we look up at the top, we know there were 30 total spools of ribbon to choose from. Again, I always start with my denominators just to make sure I know I've set those up correctly. And then I do my numerator. 7 were green, and then 7 were green again, because this is a with replacement problem. So again, if I multiply across, I get 49 over 900. And when I put that in the calculator to round it, I got 0.0544. All right, just one more. Let's take a look at the wording and see how things have changed. Find the probability of selecting 1 pink spool and then 1 that is not pink. Okay, so guys, if pink is represented with the letter P, then not pink is going to be represented with the P with a line over it for the complement of pink. So my question is, if we know there are 12 pink spools and 30 total, how many are not pink? And so I immediately want to subtract. I would take the total and then I would subtract the number that are pink. And I am going to be left with 18 total spools that are not pink. They could be green or white or gold. It doesn't matter as long as they're not pink. Take a second to think about that. So it's going to be pink and then literally anything else. So the way I'm going to write that is that first we're going to get the pink and then we're going to get the not pink spool. So for us, that would look like the probability it's pink first times the probability it's not pink. So again, denominators first. Start over 30 because we are not changing our sample space. And first, we select the pink ribbon, and then we select one that is not pink, or the complement of that. And if we multiply across, we get 216 over 900, or, again, I don't know what happened. Apparently I stopped recording, but if we multiply across, we get 0.24 as our decimal final answer. Okay? Great job keeping up with it. There's only one more example we're going to go over today.